Hello Internet! Today we're going to be taking a look at spherical gravity. This is a way to take gravity that you would normally use in your Unity games and change it from something that happens in a single direction into something that is universal and kind of works more similarly to how gravity works in the real world. So every object emits its own gravitational fields and every other object is pulled towards them. They all can kind of create like orbits and other things inside of a 3D space. This is just going to be a really quick dive into that just because I happen to need a spherical gravity solution for something that I'm working on. So that's what we're going to try to build today, and we'll kind of figure it out as we go. So I just have an empty scene here. There's nothing in the scene. I've only created this empty mono behavior, so there's nothing in this project at this point. We're going to do this in 3D space. It will be slightly different between 2D and 3D space. The only real difference is that you're going to use Rigidbody 2Ds instead of Rigidbody 3Ds, and you're going to use vector 2s instead of vector 3s. So the math gets slightly less vectory. There's one less dimension, but the actual components and what you're doing with them should be almost identical. So let's create a couple spheres. We're just going to start with one, and we're going to give this a rigid body. I'm actually going to rely on the mass component of these rigid bodies in the calculation. The calculation for gravity is G, which is the gravitational constant, times the mass of the two objects divided by the distance between them squared. So basically there's a square law. This is me not remembering. But there's an inverse square law where as things get further away, things get less and less impactful at an exponential rate. In this case, the things that we're going to care about are going to be mass and the distance between the two objects. I'm going to solve for every rigid body in the scene, just because that seems like the simplest way to do this. We'll probably do this by specifically picking out other spherical gravity emitters and doing that. But I think we could just grab the rigid bodies too. So I haven't planned any of this. We're just gonna kind of figure out what makes sense as we write this. So I'm also gonna throw this spherical gravity 3D script onto this object. And the real two things that we kind of care about are the rigid body and the spherical gravity bit. So this is our script. It's brand new and empty. So I'm going to throw in a rigid body. We'll just call it body. And we're going to grab a copy of that like that. And so what we want to do is get a copy of our rigid body. And then we're going to get a copy of every other rigid body. There's sort of two ways we can solve this. If I do this in like the start method or when it's awaking, I can collect every other object and just keep a list of all of them. This means that I don't have to scan every single frame for new objects. But it also means that if I instantiate new objects, they will not be impacted by this, and I will need to manually insert them some other way. The other option is just throw it in an update loop and do the loop constantly. In this case, I'm expecting things to kind of always instantiate and be in one place. So I'm going to create this list. However, that may not necessarily be what people want to do. It really depends on how you're planning on using the system as far as what is going to be best. And there's probably other more complicated architectures that introduce other ways of managing this. But for now, this should be plenty. So I'm just going to create a list of rigid bodies. Oops. Apologies. This is a new keyboard and I am clearly missing a bunch of keys. So otherBodies. And what we need to do is we need to go and create this list. So I think what we can do is just do some fun link things. This and do a git components and just find rigid bodies. This should go and find everything. All right, autocomplete's being real fun here. And then what we need to do is do where, sure, we'll figure this out later. So where the rigid body is not equal to itself, is not equal to body, right? So we're getting every rigid body in our scene, and we're finding the ones that aren't the one that we're looking for, and we're converting this. This saves us from a division by zero error because the actual gravity solution takes the distance between two objects squared and divides by that number. So if we take the same object or even have things overlapping, there's going to be no distance between them, and we will destroy reality, or divide by zero, whichever is the better outcome. So this sort of should help us avoid that. It won't solve this if you get rid of collision or something, or just put two objects in front of each other. You still will divide by zero, and things might not be happy. So there's other ways we could solve for that, but for this case, we're gonna just do the simple bits. So we have the body, we have the other bodies, and so what we're going to do is basically grab every other body. So for each, sure, that seems like a good suggestion. So we're going to grab every other body, and then we're going to go and calculate the distance between the two. So not car, distance equals that. That should work. So vector 3, calculate the distance between the two. Is this even using the, yeah. So that's going to get us a distance formula between them, calculate the length between these two vectors. And we'll need to square that, but we can sort of skip that. And then we just need to solve for gravity. I'm also realizing that we'll need a direction. So I think the way to do this is to get a direction vector. And I think that should work. So if we take our position, subtract the target object's position, that should get us a direction aiming towards the object. We normalize that, so we get a normalized vector, which means that it has a unit length of 1. So what we're going to do is we're going to solve for the length of the vector, which is how much force should be applied to the object. And this direction is giving us the vector in which the force should be applied in. So we're going to apply this force on the object in that direction. And this is basically going to create a vector that pulls everything towards it. So basically creating a planet or something like that. Any of those like fun 2D platformers where you kind of can walk around planets, things like that. This should give us a similar effect. So we have our distance, we have our direction. We need to solve for the gravitational constant. I'm not going to do that. It's, I think, like 6 times 10 to the 10th or something like that. This is a video game. So we're going to change things up and kind of make that value up based on whatever feels correct. We're not going to try to use the actual one, but we're going to get kind of just plug in values and see what happens. So 9.81 is the actual falling rate of an object, but the gravitational constant is a completely different constant. I'm just going to plug in like 100 and we'll see where that gets us. It might need to be significantly higher. It might need to be lower. But in this case, I want it to be like more fun than realistic. It's not a simulation. So we're going to do this, and then we want to apply our pull to every other object, not to ourselves. So otherBody.AddForce in the direction times the gravity. This is not the correct formula. So now we need to do our gravityForce and solve for that. So what this is gravityForce. These suggestions are no longer helpful. And we're going to do a gravity times the mass of the two objects. So in this case, it's going to be our body.mass divided by the distance. Going to group these things again, and we need to take the square of the distance. So I'm just going to multiply this by itself, which should be the same thing as taking a power of it. It removes the need to do a function call. So this gets us the gravitational constant, which we are defining ourselves because we can, taking our mass and multiplying those two together. So the mass of the both bodies that are impacting each other for gravity, and then dividing by the distance squared between the two objects. And then we're going to add that force onto the other object. And hopefully we'll see that get pulled in towards the object. I'm also going to make this public. And I think if I make this serializable, we should be able to see these values and the rigid bodies in the field that it's grabbed. There we go. I think that's correct. I sometimes have to guess. So let's do this. Our sphere should exist there now. Especially like if we're treating this as a planet, Earth is typically not a meter of radius or diameter. So gravity is kind of a little bit different. But let's just throw a cube in there. We'll make you a little bit bigger and give you a bit more mass. And then we can take our cube like so and throw a rigid body on here. And by attaching a rigid body to this object, our script should now find this cube and pull it into the sphere. Or I've done my math wrong and it will push it away. Or I've left gravity on and that's stronger than my gravity and everything breaks. Also a great option, not the one we wanted though. So let's turn gravity off so we can turn gravity on. And run that again. And do it in a way that is maybe a little bit more useful. So in this case, because interesting. Okay, so we don't actually have anything in our list. Let me grab this cube. I think gravity is too strong. Let's change that to 1. And let's figure out why we're not getting anything. We did get a few exceptions. My face is covering up some of the exceptions that happened. But because I was manually modifying that list of bodies, when I click plus, it introduces a null entry into the list. Our code doesn't handle nulls. So that was erroring out and throwing an exception. And then as soon as we added the object, it fixed it and broke in a fun new way. So why don't we get, that's not how you get those. So we need to do, not that. Game object dot find any object of, there we go. This is me forgetting certain functions. And we need to find this. Cool. Let's see if that fixes it. Or I might need to go and remember how to, there we go. Yeah. Okay. So our other object is pulling itself, the cube into it, which is giving it force and then giving the object itself force because the cube is running into it and they've been doing force things, physics things. But it works. So let's freeze this in place. And we're going to take this and try to get it into orbit. And I think we should be able to do that by creating another just really quick class here. And let's just do velocity. That's a really bad name for an object. So game object, not that. Rigid body. Oops. And grab our rigid body. And then what we're going to do is just set the velocity. Equal to its forward vector. So this .transform .forward times some speed constant. Oops. Okay, that's not helpful. There we go. Cool. So this speed constant is going to be what we're going to use to kind of tweak this and get it into wherever. Let's just set it to 1. Sure. I feel like I've made a mistake by calling this velocity. That's okay. So what this is going to do is just grab the physics object that we're attaching this to, and then it's going to push it along the forward axis and add a specific speed. So basically following that blue line, it's going to go forward at the speed that we tell it to. So if I say 10, it should launch off and hopefully come back like this. And now we have sort of a, looks like collapsing orbit, but we do have an orbit, right? So we can create 3-dimensional things. And then by tweaking things like the gravitational constant, what? Oh, okay. So it is still getting affected and it is slowing down. We just slingshotted it out very far in orbit. But we can get that back. All we have to do is just make gravity much better. So we crank that up to like 500 and now it's back. And now it's gone again. So this gives us like a really quick sandbox for doing 3-dimensional gravity inside of our games. I'm planning on using this for like actually doing platforming and stuff in 3 dimensions around a spherical object. But I just thought this was kind of a fun, quick way to kind of dive into this and poke around. So hopefully this was interesting. There will be code in the description below if you want to check that out. Otherwise, if there's other things that you'd like to see us cover, I guess let me know in the comments. Kind of been doing other projects that I don't involve computers. So I haven't had a lot of videos to make, but I've been getting back into it and trying to kind of fight burnout. So yeah, hopefully this was an interesting reintroduction, kind of diving back into Unity and getting a little bit of a reacquainted, I guess, with it. So yeah, thanks everyone for watching and I will see you in the next one. So until then, see you, internet.